Hello guys, welcome back to my channel. Memo African Motives are still working on engineering science N4. We are working on question papers and revisions. So in this platform we are given the question which is actually on dynamics. Okay, don't mind the spelling there. It's dynamics. Okay, so if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that you shall be having from Memo African Motives working on engineering science N4. So we are given a motor car of 1,200 kgs is at rest. All right. And at the top of a 15-meter frictionless slope of 28 degrees to the ground. When the brakes of the car are released, take note, it slides down the hill on its own, and the top and the bottom. It immediately moves on the horizontal road until it comes to a standstill after 20 meters. All right, this information, guys, it's best that we represent it in form of a diagram. Okay, this is something like we had a car which was actually at the top like this, something like this, and it's actually moving or is being taken downwards like this. Don't mind my car, guys. Do not mind this car. Okay, so this is having a mass of 1,200. So there is a mass here of 1,200. All right, kgs. This is actually here 1,200 kgs. Then what's happening? It is at the rest of the top, which is a 15 meters frictionless slope. Take note, this is the slope. So which means this 15 meters, we are referring to this. This is the slope, okay? So this is the slope here. This is where we are having your 15 meters, okay? And definitely this is going to be the perpendicular height here, okay? And the angle, you're given an angle of what? Of 28 degrees of the slope, which is 28 degrees. All right. To the ground, okay, then let's see what is happening here. And the bottom, it immediately moves on the horizontal road until it comes to a standstill after 20 meters. Okay, so this car now, like, it moved from this distance of 15 meters. This is the slope, okay? Then when it was taken downwards like this, it had to move until it has to go, until it comes to rest on a certain distance from this point here, on a certain distance, which is 20 meters. All right. Until it comes to rest, which means the final velocity from this point up to this point, the final velocity is 0 meters per second. Best that you list this information. So the initial velocity, for the meantime, we do not know this initial velocity, but it is the velocity that we are going to take from the moment the car is moving up to this point. But the final, you are told that it comes to rest, so the final is 0. Okay, so that's the information that you have. Now you can answer the questions. It becomes easier when you list this information. So what is the first question? Determine the following. The potential energy of the motor car at the top of the slope. Okay, so at the top of the slope, this is where it is. Okay, so this is 4.1. Okay, so remember that the potential energy is equivalent to mgh. All right. So if it is equivalent to mgh, how are we going to find h? That's the question. How am I going to determine h? Because I have got the mass. Okay, I've got the mass of 1,200. I've got the gravitational acceleration, but I do not have h. But I'm given this 15. So actually I'm going to find this h, which is equal to 15 sine theta, which is sine 28 degrees. How do you determine? Actually, this is from your normal solving triangles, guys, your normal trig ratios, where this is your 28 degrees and this is your 15, and you want to calculate this h. So you know that this is opposite and this is the hypotenuse. So you're going to apply sine. Sine theta is equal to opposite over hypotenuse from your mathematical skills. And so you can apply this sine theta, which is 28 degrees. So sine 28 degrees is equal to the opposite, which is h, over the hypotenuse, which is 15. So you can actually cross multiply. So h is equivalent to 15 sine 28 degrees. Okay, so this is from your mathematics, but you can just write this knowing that it's going to be sine theta. Okay, so mass times g. Let's substitute the mass. We got the mass of 1200 multiplied by the gravitational acceleration, which is 9.8 times h, which is the height, which we said it's 15 sine 28. So it's multiplied by 15 sine 28 degrees. All right, like this. So this is going to be the potential energy. Take note, guys, about this information. Okay, so if you use your calculator properly, you are going to obtain this value, this big value. Let me just write it: 814,78368, something like that. Okay, so you can actually round off after the comma here to 3 decimal places, which is going to be 82814, comma, that's 1 2 3, and if you round off, this is going to be 784 joules. Okay, or you can write it to kilojoules, or you can just leave it like that. Okay, but that is the potential energy, by the way. Then another question on 4.2, calculate the kinetic, take note, the kinetic energy of the car when it has moved 7 meters down the slope. Okay, we need the kinetic energy when it has moved 7 meters down the slope. Okay, when it has moved 7 meters down the slope, it's like this. This is the slope, which is 15 meters. Okay, take note, the slope is 15 meters and it has moved 7 meters down the slope. All right, so if it is moving 7 meters down, which means initially we had 15, but now out of 15 we are going to remove 7 because it has moved 7 meters. So this car is going to be like this. Let me show you the diagram, how it is going to look like now, because it was initially at this point, now it has moved, maybe it's at this point. So from this point where it is to the last point here, it is going to be 8 meters. Why? We had 15 and this is a 7. From this point to this point is 7. So we're going to subtract 15 minus 7. Okay, so 15 minus 7, you are going to remain with 8 meters. So now you are having a diagram like this. It is now limited to this part. The angle is still the same, 28 degrees. So as you can see, your height is going to change because initially this was the diagram like this. This was your height. Now look the height where it is, because you're now working with where the car is now. The car is moved here. It has moved 7 meters. So these 7 meters are already out. We are no longer talking about these 7 meters. So you're now working with this 8 meters. Okay. So how can we now calculate the kinetic energy after it has moved 7 meters? Okay, let's take back the information, guys, and see the question. The question is the kinetic energy of the motor car when it has moved 7 meters down the slope. Okay, so the kinetic energy when it has moved 7 meters down the slope is going to be equal to the potential energy that is lost. Take note, guys. The kinetic energy when it has moved 7 meters is equal to the potential energy that is lost. Okay, so how are we going to determine this potential energy which is lost? Okay, potential energy that is being lost is equal to the potential energy that we had at top, which we had previously at the top, minus the potential energy that we are going in correspondence of the 7 meters after 7 meters, which means the potential energy now that you have when you are with this 8 meters, because remember the potential energy is going to change, because initially you use the potential energy with the h, this h which we said it's 15 sine theta, but this time our h is no longer 15, it's now 8 sine 28. Okay, so that is why the potential energy is going to change. So which means you have to find the potential energy after moving 7 meters. So this is after moving 7 meters, so it's going to be mgh, which is the mass. The mass is not going to change, it's going to remain as it is, which was 1200 multiplied by 9,8 multiplied by h. Now the h, we are now working with 8, so it's 8 sine 28, just like what we did on the previous question, guys, but now you are using 8. Okay, so this is going to be the potential energy, which is going to give us this big value. Let me just write it, 167,88, yeah, something like that, 545, like that. So if you round off, this is, suppose this is 63, so if you round off, this is going to be 44167,885, because this is 4, so it's going to be 885. Okay, so this is 44, guys, which is in joules. Okay, so this is the potential energy that you're having after moving 7 meters. So the one that is lost, which is equivalent to the kinetic energy, is the difference between the one that we had before. This one at top is the one that we calculated. The first potential energy is the one that we calculated. Remember, we were asked here on the first equation the potential energy of the motor car at the top of the slope. Okay, at the top of the slope. So this is the one that we calculated. Is this the one, or it's here? Okay, this is the one. This is the one that we had the potential energy. So this is actually EP top. All right, so that means I'm just going to substitute, since I need the potential energy lost, which is equal to the kinetic energy after moving 7 meters. I'm just going to write this as EP lost, the potential energy lost, which is equivalent to them. The potential energy at top, I'm going to use that value that I had, so make sure that you substitute these values properly. So it's 82814,784, something like this, minus I subtract, remember I'm supposed to subtract this one at 7 meters, which is this one, this value that you obtained. Okay, so you just substitute that value as it is, 44167,885. all right, so guys, make sure that you use your calculator properly. Okay, you use your calculator properly here, you're going to obtain something like 386. I don't know if I was using the calculator file, but that is what is you're going to obtain, 899 joules. But we said this potential energy that is lost is equal to the kinetic energy that is after 7 meters. So that means we are having the kinetic energy after moving 7 meters, which is the one that we wanted to calculate. But as you can see, we had to use another way in order to obtain the answer, which was supposed to be direct, but we had to move around because we have moved 7 meters. So we are going to remain with 8 meters, so that if you add 8 and 7, you must obtain 15. And the height is going to change because you are now working with what? With 8. So that's how they ask these questions, guys. So you have to be very, very careful about these questions. Okay, let's see another question, which is got 5 marks. Why are we having 5 marks there? Okay, on 4.3, the time it took the motor car to travel on the horizontal road until stand still. All right, the time it took for the motor car to travel on the horizontal. All right, if you cross-checked properly on the diagram that I drew here, there was something like this here. This is the car after it moved here, it has to move on this. This is the straight line. So this is the information that we have for this straight line. This is the information that we have, and the question is actually referring back to this information, but we need to calculate the time. So from this information, where can we have the time? Okay, initially we just have these two values, the distance and the final velocity. Guys, this information is too shallow. We need a lot of information. All right, let's start with the initial velocity. We can have this initial velocity. Why? Because when this car was actually moving, it was using kinetic energy. Remember, kinetic energy is the energy that you're actually applying when there is a movement. All right. So when this car was moving, it moved until this point. We are talking about the slope. Or along this slope, it moved until this point. So at this point, it means, take note guys, at this point that I'm indicating here, it means the car is possessing the maximum kinetic energy that it had at this point. It is possessing the kinetic energy. So if it is possessing the kinetic energy, it means I can find velocity when it has this kinetic energy. Why? Because in kinetic energy there is velocity, because remember the formula is half mv squared. There is velocity there, and this velocity is the final velocity, of which the final velocity when it is down the incline is the initial velocity when it is moving on the horizontal line. Take note. Yes, it was your final velocity when it was moving down the incline, but once it's moving now the horizontal part, this final velocity becomes your initial velocity, because already we are given that it finally comes to rest. So that's your final velocity there. So the final velocity from the incline becomes your initial velocity on the straight line. That's how you take this. Okay, so we need to find this final velocity. So where can we have this information? We just need to make v the subject. Okay, so let us make v the subject here, or you can just replace the information. Okay, as for me, I'm just going to prefer to make v the subject. I'm going to cross multiply 2 times ek, the kinetic energy, which is equal to mv squared, divide by m, which means I'm going to have like v squared, which is equal to 2ek like this over m. Okay, so to find v, I'm going to put the square root, so that means v is equivalent to the square root of 2ek over m, like this. Okay, so now let's substitute everything. So we've got the square root of 2 times the kinetic energy. All right, the kinetic energy, we got this before. Remember the kinetic energy, it was 8. Okay, in fact we didn't calculate this kinetic energy. We didn't calculate it direct. We know that on the final position, from this concept of energy, remember when you're working with energy, when you have potential energy here, the kinetic energy will be equal to 0, and you're going to obtain kinetic energy at the end, and here you are going to have potential energy, and these two, they are equal at the end. Remember that concept, that from the law of conservation of what? Of energy. So the potential energy at top, this one is equal to the kinetic energy. The potential energy at top will be the one that you're going to use as the kinetic, and the potential energy at the top is the one that we calculated on the first part. Remember, we obtained 8. It was 8 the potential energy at the top, the one on first item, it was 8214,784, like this, everything over the mass of 1200. Guys, remember the information that we had. Do not leave this information here. We are still using the same mass of 1200. Okay, so if you use your calculator properly here, you are going to obtain the velocity. Okay, so the velocity of 3,7 meters per second, which is the one that we are saying it is now going to give us the initial velocity here when we are working with what? With this information. So now we've got the initial velocity, which is 3,7 meters per second. Okay. All right. So still we have got initial velocity, final velocity, the distance, the displacement or distance, but still we can't find t. Which formula can we use? These are the formulas, guys, and we can cross-check the one that we need because we want to calculate the value of t. There's no formula that we can actually use that connects these together. All right, so what am I going to do? I can actually use this one because I've got v, u. I can calculate acceleration, okay, first, so that I can use this one to calculate now the time. Okay, so I can use that formula to calculate the acceleration first. So it's a matter of playing around with the formulas, guys. Okay, so let's find acceleration. Is it possible? Is it possible to use this one? No, it's not possible because here we need t. We need t here, guys. So I can use this one. Yes, I can use this one because I've got v, u, t, and yes, I can use this one. V squared is equal to u squared plus 2as. All right, so that's why it has got 5 marks, guys. You see, there's a lot of work that you're supposed to do. V squared is equal to u squared plus 2as. Let us make a the subject, so it's going to be v squared minus u squared, then divide by 2a. So you divide by 2s, not by a, by 2s, so that you obtain a. Okay, so a is now the subject. You can substitute v. Remember, v is the final velocity, which we said our v, it says 0 there, that's 0, minus u squared, the u is the 3,7, so you've got 3,7 squared like this, over 2 times s, which is the displacement or the distance which was actually taken, the displacement of 20 meters because it's a straight line. All right, this is what we are having in this case. Now, if you are to use your calculator properly, you're going to obtain this negative 0.342 meters per square second. Remember, it's acceleration, guys, which is meters per square second. All right, then I have got the acceleration now. All right, let's write the acceleration is negative 0.342 in meters per square second, like this. All right, then I'm now asking myself that how can I connect these now to calculate t? Now I'm back to this basic formula, this one that I ticked here, where I said v is equal to u plus at. As you can see, this one is now the easiest one that you can apply because you got the v, you got the a, you got the t. All right, so let's substitute, or let's use this formula. V is equal to u plus at. All right, and I want to calculate the value of t. Guys, just look how it took, and this just 5 marks for that. So let's transpose for t. So it's v, u to the side is going to be u like this, over, because the moment you transpose, you're going to be left with at. So to remove this a, you're going to divide by a, which is going to give us t. All right, finally we got the value of t. So let's substitute our v, which is the final velocity, that is a 0 there. So we got 0 minus the initial velocity, all right, which is 3,7. So you got 3,7 over the acceleration. All right, remember we got the acceleration, which is a negative, this one, negative 0.342. all right, so that's what we had as the acceleration. So dividing these guys using your calculator, you are going to obtain something like this, 10,819. all right, 10,819 seconds. So this is going to be the time which was taken, guys. Just imagine, for 5 marks that we had to go through this process. But the moment you work with more question papers, guys, I want to advise you one thing: work with question papers so that you understand what you're doing. The more you work with more question papers, actually you know that when I'm given a question like this, I can answer in this way. So you have to be used to question papers. Okay, so that's it, guys. Working on engineering, science, and form from Mason African Motives. So if you're new to this family, you can consider subscribing so that you won't miss any of the classes that we shall be updating from Mason African Motives. That's it, guys. Till we meet again.